Hi guys, today we are going to cover a section of pressure, definition of pressure, equation, SI unit for pressure, minimum and maximum pressure, examples, like a pro. Let's do the definition of pressure. So we'll say pressure, this is the force acting perpendicularly or normally a unit area. What does this mean? It means that if you have the following, let's consider a cardboard, and you're exerting a force on that cardboard, a force F, and let's say the force is at an angle of 90 degrees with the cardboard, such that it's exerting some force on an area A. Pressure will be equal to this force divided by the area that this force is acting on, and ensure that the area is the force and the area, they are at 90 degrees. They must be at 90 degrees, and that's the meaning of perpendicularly or normally per unit area. That is the meaning of that. From what we've learned, pressure is equals to force over area, and therefore the SI unit of pressure must be force, which gives us Newton, and area, which gives us meter squared. And therefore, because we are dividing these two, we'll say the SI unit is Newton per square meter. In honor of the scientist Pascal, 1 Newton per square meter is equivalent to 1 Pascal. And therefore, another SI unit for pressure is Pascal. And the symbol for Pascal is P small a. From the formula, pressure is equals to force over area. It is evident that when you increase force, the pressure increases. When you increase area, the pressure reduces. So F, when it increases, when F increases, P increases. And when area increases, pressure reduces. And this brings us to maximum and minimum pressure. Maximum and minimum pressure. Consider a book of weight 2 newtons. So this book and this one are identical, and they all have a weight of 2 newtons. So we'll say for this book, let's say in a position where it's facing, where 8 centimeters and 4 centimeters are facing downwards, that is, they are the ones that are in contact with the table, the area will be very small, and actually the area will be 8 times 4, which is equal to 32. square centimeters. But when 10 and 8 centimeters are facing the table, that means it's resting on the 10 and 8 centimeters, area will be 10 multiplied by 8. That will be 80 square centimeters. There's also another option, a case where the first 4 centimeters and the first 10 centimeters are facing the table. And this is that face. When this face is the one that is facing the table, this will be the results. So a case where you have an alternative, an area where the table, the whole book is resting on the table on the face, where the first 10 by 4 are facing the table, will have an area of 40 square centimeters. Now, because we've kept the weight to be a constant, you'll see that these areas will give us different values for pressure. So let us label the areas. Let's say this area is A, this one is B, and this one is C. So A gives us the area of the surface A gives us a total area of 40 square centimeters. Total area for A of B gives us an area of 8 by 10, that is 80 square centimeters. And A of C will give us 4 multiplied by 8, that is 32 square centimeters. Now, let's write using these areas. We know because of the difference in areas, and therefore we are going to have the differences in pressure, considering that the weight of the whole book is 2 newtons. So pressure, when the area is very small, for example, this one, this is the smallest area. Pressure, when the area is very small, will be the weight of the whole book divided by an area that is very small. And that area, we call it minimum area. So a minimum area means that the area is very small and therefore the pressure is supposed to be huge. Maximum pressure. What about when the pressure, a case where the area is very huge? So pressure is equals to, when the area is very huge, we say that it would be weight. Now the weight acts as our force divided by an area that is very huge. An example of an area that's very huge is this one. This is the largest area, so we'll call it maximum. Now, because the area is very small, the area here is very huge, therefore the pressure will be a minimum. And these are the two formulas for minimum and maximum pressure. Remember, area is inversely proportional to pressure. When you increase the area, the pressure reduces. When you reduce the area, the pressure increases. So when it's an area is minimum, the pressure is supposed to be maximum. When the area is maximum, the pressure is minimum. Example 1. A man of mass 84 kg stands upright on a floor. If the area of contact of his shoes and the floor is 420 square centimeters, determine the area, the pressure he exerts on the floor. Take G is equals to 10 newtons per kg. So you're going to write down everything that we have. We have the mass, which is 84 kgs. And therefore, from the mass, you can have the weight, because weight is equals to mass times gravity. So that gives us 84 times 10. And that's a weight of 840 newtons. And the weight will act as our force. Therefore, our force will be 840 newtons. What about the area? The area is given as 420 square centimeters. We are going to convert this to SI units. That will be 420. Then we multiply by 10 to the power of negative 4. And the answer will be in square meters. Now, the next step will be to write the formula for pressure. Pressure is force over area. From what we already have, we'll say that the force is 840 newtons. The area is the whole of this one, which is 420 multiplied by 10 to the power of negative 4. Pressure is equals to, when you key in the whole of that into the calculator, ensure that the force is in newtons and the area is in square meters, which are the SI units, so that our final answer can be in pascals. The answer is 2 times 10 to the power of 4 pascals. You can also say, or Newton per square meter. Example 2. A metallic block of mass 40 kg exerts a pressure of 20 newtons per square meter on a flat surface. Determine the area of contact between the block and the surface. So the mass is 40 kgs. That means the weight is mass times gravity, which is 40 multiplied by 10. The weight is 400 newtons. The pressure is given as 20 newton per square meter. Determine the area of contact between the block and the surface. So from the formula of pressure, pressure is equals to force over area. We are looking for area. So we say area is equals to force over pressure. Now substituting the whole thing, we have a force which is equivalent to 400 newtons and a pressure which is 20 newton per square meter. So area is equals to, you key in the whole of that into the calculator and the answer is 20 square meters. Example 3. A block of copper of density 8.9 grams per cubic centimeters measures 5 centimeters by 3 centimeters by 2 centimeters. Given that the force of gravity is 10 newtons per kg, determine the maximum pressure, that is A, and B, the minimum pressure that it can exert on a horizontal surface. So you say for A, P maximum must be equals to force divided by A minimum. That is the formula for maximum pressure. Now for us to solve this problem, we first need a force. Then we need an area. So when you look at our value here, we have the density and some few dimensions. So we need to calculate the volume because we have a density of 8.9 grams per cubic centimeters, grams per cubic centimeters, which is equivalent to 8,900 kgs per cubic meter. Volume, the volume is 5 by 3 by 2, which gives us 30 cubic centimeters, which is also the same as 30 times 10 to the power of negative 6 cubic meters. That is when it's written in SI units. Now, with these two values, we can calculate the mass. So the mass will be the density times the volume. So that is 8,900 multiplied by 30 times 10 to the power of -6. So the mass will be equal to, when you key in that into the calculator, 2.67 times 10 to the power of -1 kgs. Now the weight will be mass times gravity. So just take that mass, 2.67 times 10 to the power of -1 multiplied by 10. So the weight will be 2.67, because 10 to the power of -1 multiplied by 10 will cancel out. So the whole final thing is 2.67 newtons. So we first need to calculate the minimum area. Now that you have the weight, it will be simpler. The weight is equivalent to the force. So you just need the minimum area. The minimum area, we pick two values from these dimensions that will give us a very small area. Remember, it's 5, 3, and 2. So 5, 3, and 2, the dimensions. So 5 and 3 will give us an area which is 15. 5 and 2 will give us an area which is 10. Then 3 and 2 will give us an area which is 6. So those are the areas of the three surfaces. You can clearly see that the minimum area is this one, of course, in square centimeters. So you're going to say pressure is equals to, and this is a maximum pressure, is equals to force all over A minimum. So in this case, the force will be the weight, and the answer was 2.667. Then we divide the whole thing by this small area, which is 6. Then you convert it to SI units by multiplying by the 10 to the power of -4. So we can have the final answer by just keying in the whole of that into the calculator. The answer is 4,450 pascals. And of course, we're going to say it's pascals because the force was in newtons and the area was in square centimeters. For minimum pressure, that is part B of the question, we are going to write the formula for minimum pressure. We'll say P minimum is equals to force divided by A maximum. So we need a force where the answer was 2.67 newtons, but A minimum, the answer from what we calculated earlier, was an area that's a maximum, that is 15. So we'll go back and say the answer here is 15 square centimeters, which is equivalent to 15 times 10 to the power of -4, 10 to the power of -4 square meters. So we are going to calculate a minimum pressure by saying the force is 2.67 and the area is 15 times 10 to the power of -4. When you key in that into the calculator, we'll say P minimum is equals to 1,700 and 80 pascals. And of course, it's pascals because the force was in newtons and the area was in square centimeters. This is the final answer for part B of our problem.